Chapter 9, Force and Laws of Motion, Class 9th CBSE based. Syllabus, Force and Motion, Newton's Laws of Motion, Action and Reaction Forces. Inertia of a body, inertia and mass, momentum, force and acceleration. 1. Force and motion. Force is a push or pull on an object that causes a change in its state of motion or shape. It is a vector quantity, meaning it has both magnitude and direction. Effects of force. Starts motion. A stationary object, like a football, can be set in motion by kicking it. Stops motion. A moving object, like a bicycle or car, can be stopped by applying brakes. Changes direction. The direction of a moving object, like a bicycle or car, can be changed by steering. Alters speed. The speed of a moving object, like a car, can be increased by accelerating or decreased by braking. Modifies shape and size. The shape and size of an object can be changed, like hammering a metal block into a thin sheet or breaking a stone into pieces. Types of forces. A. Balanced forces. If the total of applied forces equals 0, the forces are balanced. Example, in tug of war, if both teams pull with equal force in opposite directions, the rope doesn't move because the forces are balanced. Balanced forces do not change the state of an object. They are equal in strength and opposite in direction. Balanced forces can change the shape and size of an object. Example, squeezing a balloon from both sides changes its shape and size. B. Unbalanced forces. If the total of applied forces is greater than 0, the forces are unbalanced. An object at rest can be moved by unbalanced forces. Unbalanced forces can move a stationary object, increase the speed of a moving object, decrease the speed of a moving object, stop a moving object, change the shape and size of an object. Laws of motion. Galileo stated that an object moves at a constant speed if no forces act on it. This means if an object is on a frictionless path with no other forces acting on it, it would move forever. There is no unbalanced force on the object. However, in reality, it is impossible for any object to experience zero unbalanced force. Forces like friction, air resistance, and others are always acting on an object. 2. Newton's laws of motion. Newton's laws describe the relationship between the motion of an object and the forces acting on it. There are 3 laws. First law of motion, law of inertia. This law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This property of an object to resist changes in its state of motion is known as inertia. Example: if a book is lying on a table, it will remain there until someone applies force to move it. Similarly, a rolling ball will keep moving in the same direction unless friction or another force stops it. Newton's first law of motion in everyday life. Bus starts moving. A person standing in a bus falls backward when the bus starts suddenly. This happens because both the person and the bus are initially at rest. When the bus moves, the person's legs move with it, but the upper body tends to stay at rest, causing the person to fall backward. Bus stops suddenly. A person standing in a moving bus falls forward if the driver applies brakes suddenly. As the bus moves, the person is in motion with it. When the bus stops abruptly, the person's legs stop with the bus, but the upper body continues moving, causing the person to fall forward. Shaking wet clothes. Jerking wet clothes before hanging them helps remove water droplets. The sudden motion makes the water droplets, which tend to stay at rest, fall out of the clothes, helping them dry faster. Striking carom board coins. When you hit the bottom coin of a stack on a carom board with a striker, only the bottom coin moves. The rest of the coins remain in place because they tend to stay at rest while the bottom coin comes into motion. Mass and inertia. Inertia is the property of an object that resists changes to its state of motion or rest. It is measured by the object's mass. The greater the mass, the greater the inertia. This means a heavier object has more inertia than a lighter one. Simply put, inertia is an object's natural tendency to resist any change in its motion or rest. Because a heavier object has more inertia, it is harder to push or pull a heavy box than a lighter one. Second law of motion, law of acceleration. This law states that the force applied on an object is directly proportional to the rate of change of its momentum, and this change in momentum happens in the direction of the applied force. In simple terms, the law establishes that F is equal to m times a, meaning force equals mass times acceleration. The SI unit of force is Newton, N. 1 Newton, when an acceleration of 1 meter per second square is seen in a body of mass 1 kilogram, then the force applied on the body is said to be 1 Newton. Example: if a car of mass 1000 kilograms accelerates at a rate of 2 meter per second square, the force needed to accelerate the car is F is equal to m times a is equal to 1000 times 2 is equal to 2000 n Newton. Third law of motion, action and reaction. This law states that for every action, there is an equal and opposite reaction. This means that forces always occur in pairs. When one body exerts a force on another, the second body exerts a force of equal magnitude and opposite direction on the first body. Example, when you push against a wall, the wall pushes back with an equal and opposite force. That's why you feel resistance when you push hard on a stationary object. 3. Inertia of a body. Inertia is the property of an object to resist changes in its state of rest or uniform motion. Inertia depends on the mass of the object. Greater the mass, greater the inertia. Example, a heavy truck is harder to start moving or stop moving than a bicycle because the truck has more mass, and hence, more inertia. 4. Inertia and mass. Mass is a measure of the amount of matter in an object and is directly related to its inertia. An object with a large mass has greater inertia and requires a larger force to change its state of motion than an object with a smaller mass. Example, it's easier to push a small rock than a large boulder because the boulder has more mass and therefore more inertia. 5. Momentum. Momentum is the product of an object's mass and velocity. It is a vector quantity and represents the quantity of motion of a moving body. Momentum is directly proportional to both the mass and velocity of an object. If either mass or velocity increases, momentum also increases. Formula: momentum is equal to mass times velocity. Here, p is the momentum, m is the mass, and v is the velocity. Example, if a car of mass 1000 kilograms is moving at a velocity of 10 meters per second, its momentum is P is equal to m times v is equal to 1000 times 10 is equal to 10000 kilogram meters per second. 6. Force and acceleration. According to Newton's second law, when a force is applied to a mass, it produces acceleration in the direction of the force. The acceleration produced is directly proportional to the applied force and inversely proportional to the mass of the object. Formula: F is equal to m times a, force is equal to mass times acceleration. Example, if a force of 50 N is applied to a mass of 10 kilograms, the acceleration produced is A is equal to F divided by m is equal to 50 divided by 10 is equal to 5 meter per second square. Summary of formulas. Force, F is equal to m times a, force is equal to mass times acceleration. Momentum, P is equal to m times v, momentum is equal to mass times velocity. Newton's first law, related to the concept of inertia. Newton's second law, F is equal to m times a, force is equal to mass times acceleration. Newton's third law, force of action is equal to force of reaction.